Hi, and welcome to this look at a buffer pH multiple choice question. So this is going to be the kind of multiple choice question that you simply just have to knuckle down and do it. It's not one of those ones where you can straight away discard two answers and have the processing time by having two possible right answers left. This will be a time bandit, so you just need to plan for this kind of question popping up in a multiple choice section of a physical chemistry paper. So start out by having a look at what the two components are, then that allows you to decide how you're going to do the calculation. So what's on our favourites is a simple acid-salt mixture, so there's no reaction taking place such as in a partial neutralization or such like. So there's no change in moles, so there's no need for the ice method or similar techniques to work that out. But you still need to be able to visualize what's going on when the two buffer components are put together, because their concentrations will change because they will have a new total volume. So one way to do that might be to visualize the two components in two separate beakers mixed together and poured into a larger beaker. So let's imagine that. Sorry about the very basic artwork there. So my propanoic acid 200 centimeters cubed of, and then my sodium propanoate 600 centimeters cubed of are in those two beakers to start with. So add them together and you get a mixture. Now nothing's reacted yet. This is literally just those two components swirling around together in that larger beaker. 800 centimeters cubed obviously is the new volume. So looking at the 200 centimeters cubed of 2 mole per decimeter cube propanoic acid, the number of moles present in that part of the buffer is 0.4. Doing the same thing to the sodium propanoate, the number of moles present in that part of the buffer is 0.6. So once mixed, because there's no reaction, those two values don't actually change, but their concentrations do. So for example, the concentration in the new mixture of the propanoic acid is going to be 0.4 over the total volume. Now the volume in total is going to be 800 over 1000, so that's going to make 0.5 moles per decimeter cubed. We need to do the same thing for the propanoate as well. So looking at the propanoate, that's 0.750. So now's the time to make those two numbers work for us. So we've got the Ka value, and we want the pH of the buffer solution. So you start off by writing out a Ka expression, putting in the actual formulae of the acid and the salt in the concentration terms. And obviously you want to isolate H+. So we know what all these other values are apart from H+. So you need to do some rearranging and now insert the numbers. So putting that into a calculator gives you 8.8 times 10 to the minus 6. It's actually 8.8 recurring, so I'm just going to leave it as a truncated version there. Now obviously that goes into a pH calculation, minus log of 8.8 times 10 to the minus 6, and you always put pH to 2 decimal places. That gives us 5.06, which is obviously answer C. Okay, thanks for listening. As always, until next time, see you soon.